You ever talk with somebody and they're talking about a free spin device and they say, oh, well, you could just stick a generator on that and just power your whole house. But you can't get them to understand that when you tie a load to this free spin device, your free spin is gone. Well, you can maybe show them this or maybe demonstrate this to them. I'll just give you an example here. So if you take a motor, this just is a DC brushless motor. You can come up with these out of printers and all kinds of stuff. They're everywhere, literally. So you spin this with nothing connected to it, and you feel plenty of spin there. I mean, I wouldn't call it free spin. There is some resistance there just with the weight and the material alone. So if you just spin it, you can kind of tell, though, that there is a little bit, after you let go, it still tries to spin. You see? I don't know if you can really see that. It's kind of hard to see with my movement and everything. But the point is, if you take and just short out the leads on the motor, this is just an easy way to get somebody to understand what you mean by tying an electrical load to it. You can see this is just shorting these leads out. So you're taking the energy and just shorting it back to itself. And you can spin the motor, but that free spin you had is gone. You can literally feel the resistance there when you try to spin the motor. And the faster you spin it, the harder it really is to go. Because you're constantly, if you're spinning faster, you're sending constant voltage. Where if you're doing this, that voltage dies out. But still yet, there's still enough resistance there that it stops the motor. As opposed to this with just a little bit of free spin. You can hear it, literally. See? Now let me tie this back up. It's gone. Yeah, I'm trying to spin it with the same amount of force. All right, so just a good little example you can show somebody. These DC motors, brushless, are pretty unique. So you can get, they are polarity specific. You can you see a DC out of it. You can also see AC voltage out of there too. So if I take this meter, let's just say, your AC is a little more constant than what your DC is, and I'll show you with this LED. So with our meter set to, now let's range this right there. That way the meter doesn't cut out of range. And you see you can keep this spin, but you're keeping a constant voltage there, or what appears to be a constant voltage anyway. And that's just the little bit of free spin that you're getting out of this motor. But check this out. So if you take an LED, and I'm not going to be able to show you, and maybe I can, anode and cathode. So our cathode may be hard to see because it's hard for me to see. I think it's on the right. Well, let's just test it out. If it's on the right, we should be negative here, positive here. Let's just stick that in there. All right. Now, without hooking the motor up, I can tell you what's positive and negative just from this LED on the direction I spin it. See, if I spin this way, I got positive here and I got a negative back here. See, and the LED pulses. But let's go back over here to the meter and put it on DC. Let's just range that. You see, it's a little harder to see the DC as a constant voltage on there. Now, if I spin this way, you can see the LED does nothing. Nothing. Well, it's because when I spin this way, I'm changing the polarity here. The negative is here and the positive is over there. So it's opposite. But, if you turn the LED, you can prove that. Turn the LED around. Spin this way. And you see, now if I'm spinning this direction, and swap the polarity, you can also see over here, you see this little negative. That tells you your polarity is reversed on your meter leads. It's pretty cool. I'll get more in depth about this, the AC and the DC on these motors in another video, but I just thought I'd show that. It's pretty cool to go with the whole free spin. A lot of people talk about free spin and what you can do with it and this and that, but their dreams are shot down when you really get them to understand this, that tying an electrical load on it, there goes your free spin. You have to have some kind of driving force. All right, thanks for watching, guys, and don't you dare subscribe to this channel.